Hi, Assalamualaikum. Okay, this is the second circuit configuration that using FET device. Okay, now I want to show you how we wanna to do the DC analysis for this circuit. Okay, so before we go into detail, let's see what is the difference with the self bias and fixed bias that you learned in previous video. So can you see at this area, okay, the RG, there is no VGG. Okay, so for the self bias, remember, no VGG at gate. Okay, because this is the gate, right? Gate. So it's only RG. Okay, the rest is okay. There is another one. There is RS. RS is added at S. Okay, so there is two different between self bias and fixed bias. Okay, so we go to the example. Okay, the question is same. To find the VGSQ, IDQ, VDS, VD, VG and VS. Okay, let's examine the circuit. Okay, the IDSS is 8 milliampere, VP is -6. Okay, so what you will do to start the analysis, it must be the DC equivalent circuit. So please draw your DC equivalent circuit. Okay, remember which part is important now is this one. Then the RG is removed. Okay, RG now is shorted. Okay, it's shorted because its value is very large and we know that the IG equal to 0. So we make it become short circuit. And then we know that when G here, there's nothing at here, only ground. So we can say that VG now equal to 0. Okay. And then, okay, this is for the VDD. Then, okay. Next, for this mathematical method, okay. Mathematical method, we need to find two equations. First, for the VGS. Okay, equation for the VGS. Second one for the ID. Okay, now let's find VGS. Okay, so VGS is here. And I do loop from here. And we got, okay, so the equation start with positive VGS. Okay, then I plus here. Plus because the current flow, okay, the IS or ID equal to ID, flow from D to S. So because of that, this is positive. Okay, so the equation become VGS plus ID RS equal to 0. And we get VGS equal to negative ID RS. Okay, now RS, there is a value 1 kilo ohm. Then ID equal to 1 kilo ohm. So this is the equation. Okay, like it's not like a fixed bias where the VGS already get its answer, its value directly from the VGG. Here, there is an unknown value for the ID. So, I can't solve this equation. So, let's say I put this equation as equation number 1. Okay. Then, okay, we go next for the ID. Then, for the ID, we use Shockley equation. So, using this equation, insert the IDSS, insert the VP. Now, so this is the equation for the FET. So I give its name is equation number 2. Then we need to solve these two equations. Okay. So here I already done the equation from the VGS. Okay. VGS equal to negative 1 KID, equation number 1, and this is the equation for the FET. Okay, you see here the VGS. Okay, so means that we insert equation number 1 into VGS. Okay, and then we solve this equation. So after I insert equation number 1 into equation number 2, I get ID equal to 8 multiply with 1 minus and then the negative KID and negative 6 squared. Okay, then this equation, okay, must be solved. Okay, so please expand this equation first. Okay, expand this equation first. Okay, then I get this value. Okay, then I expand this equation. It become like this. Okay, this one already multiply with 8. Okay, so I get this. Mean 8 milli minus 2.67 ID plus 222.3 ID squared. Okay, this one is equal to ID. So remember that. Then we need to make this equation equal to 0. So bring the ID here, okay, because this is the ID. Bring this ID here. So rearrange the equation. It become 222.3 ID squared minus 3.67 ID plus 8 milli equal to 0. You see here the two this value, okay, already added with the ID, and here becomes 0, here becomes 0. Okay, now this is the quadratic equation. Okay, so you know that the first one at the ID squared here, this is A, and this is B, and this is C. Next, to solve this equation, okay, we use this formula, the quadratic formula. Okay, you use this equation, insert A, B, and C here. Then calculate. Okay, after I calculate, I get ID. Okay, I get 2 ID because we already have a square here. So I get ID equal 93 milliampere and 2.58 milliampere. Okay, we have 2 ID. So this is ID number 1. This is ID number 2. Okay. So which ID actually is the correct value, okay, for this question? Okay, because we have 2 ID. So ID 2.58 milliampere is taken due to ID 13.93 milliampere is out of range because the maximum value of ID is IDSS, which is 8 milliampere. Can you understand? Okay, let me explain. Okay, we have the curve, right? So the IDSS here is the maximum current, which is 8 milliampere. Okay. So remember that the range, this is the range, okay, for the current. Now we have 2 ID. One is 2.5, somewhere here, 2.58, and another one is 13.93, somewhere. It exceeds its value, okay, means here, okay, 13.93. You see, this value is out of range, so it's not valid. Okay, you must use 2.58 milliampere, okay, for the current.